How Test Scores Affect Eventual Income, an AP Statistics final project by Nathaniel Bernstein. So, the question that I posed at the very beginning of this final project is, can a test score actually effectively predict a person's starting and or mid-career annual income? So the reason that I chose this question was there's a constant test score obsession within our society today, especially in high school, and I noticed this particularly senior year. And so one of the big things that happens is people get tutored for test scores and constantly do all this stuff to get a higher test score. But there's been a lot of calls to question of whether or not a test score actually measures how smart you are. So I really want to know whether this test score can really predict not necessarily your smartness, but your eventual income, which is often seen as something that shows whether you are smart or not. So my prediction was, I believe that test scores will predict income to a certain degree. However, there will not be as big of a difference as some people might expect. I believe that people think the test score really measures a lot about you, and I don't necessarily buy into that belief. So I thought it would be helpful in predicting, but it won't necessarily be all or none, because I think there are a lot of people who probably have low test scores and are very rich. So, my two methods which I used to measure this were a regression line. This gives me a correlation coefficient and shows whether there's a linear relationship between test score and income. And I also used a two-sample t-test, which helps show the difference between high-score incomes and low-score incomes. Here's a histogram of the different test scores. So, I was not able to get any really below 800 because that is very, very extremely low. And then the highest test score was around 1500s. These are the averages of different colleges, so it's taking the low score and the high score and adding those up and dividing them by 2 to get it. So as you can see, the most frequented was between like 10,000 and 1200. It's approximately unimodal, kind of symmetrical, so it works well. Here is a box plot of the test scores. The good thing about this, and the reason I showed it, is that there are no outliers. So that was a very important thing, so that there wasn't like a crazy test score, which there wasn't any accounting for, because that could very much skew the different tests that I was doing. How I got my data. So I used a website with the mean starting salary and mean mid-career salary of every single college in the world, and it was ranked. And then I used a random number generator, and I would randomly generate 10 numbers at a time and just go through, and every number that it was, I would go to that of the college. And then if there was a tie, because there were a bunch of ties, so like let's say 67 had the rank 67 had 3, then I would do another random number generator from 1 to 3 and choose it based on that. And I luckily was able to get a very diverse set of scores and set of colleges. And then those colleges, I searched for their SAT scores and found those online using different methods from just mainly from the college's websites. I then took the mean of the high and low score, as I already talked about, and this data helps show whether test scores might relate to the eventual monetary success. The linear regression line, my first test. Here is a linear regression graph of the test score versus starting salary. As you can see, it's pretty linear. There's some points which are a little bit affecting, like the 1500 and 60,000. So that's a little bit kind of off from the rest, as well as the 12,000 and 1200 and 31,000. So those two are kind of farther away from the rest, but overall the fitted line seems about accurate. So that's a very good thing. So here are the numbers, and this basically just gives, if you were to input a test score, how you would predict the starting salary. And the R-square is 50%, so it accounts for 50% of the variability in the distribution. So I think that's pretty good overall for a test that takes a lot of, didn't have that many colleges, and is a test that's kind of using not necessarily the best information, but that which was available. This is the scatter plot of median career salary versus test score. As you can see, it's a much stronger slope, so it's a much more positive correlation. It's much steeper, and so that was very interesting. So even though starting career salary might not be as affected, median career salary seems to be, and this is further evident by the numbers, with an R-squared value that's even larger, which means it accounts for more of the variability, which is great because that means that it accounts for a lot of the in general test. And then here are those two compared. As you can see, as I already pointed out, the slope is significantly steeper for median career salary. So next I did a 2-sample t-test. Here is my work that I did for the different 2-sample t-tests. On the first one is the mean starting career salary, and the other one is the mid-career starting salary. Here's how I divided up the colleges. I did not use all the college data in this. I wanted to have a larger break, so the low-scoring colleges are those, and the high-scoring colleges are the other ones. And the interesting part about this, the cutoff was like for high-scoring colleges, I think was 1165 average SAT score, and then a low-scoring college, the average SAT score, the cutoff one was around 800, 900. So here are the two box plots. Actually, the low scoring college cutoff was like 1000. So this is an interesting thing to show the differences. And there's I tried to not have many from the middle. And then here's the box plot of mid-career salary versus mid-career of the two different mid-career salaries. As you can see, the mean is significantly different. The mean of the high SAT score was near 100,000, and the mean of the low SAT score was less than 60,000. So it's very affected by it. And then the starting this is the starting salary. What I found really interesting about this was 3 of the points in the high SAT score were outliers, and there were only 12 data points in general for that. So that was something that I did not necessarily expect and could have possibly had an impact on my data. So my findings. The difference is obvious both by looking and after completing the tests, and both tests proved what I hypothesized. I actually think that SAT score might even have a bigger effect, not that it causes, but as SAT score rises, income rises even more, as seen in the mid-career salary range. There's a clearly linear relationship with, as seen through the linear regression line, and the p-values are extremely low for the 2-sample t-test. My conclusions. A high SAT scores correlate to income, both mid-career and starting salary. Test scores can be used to predict income, but what everyone needs to remember, including me, is that correlation does not prove causation. So just because someone has a high SAT score doesn't mean that they are going to have a high income. And then SAT scores are useful and not just a non-entity number of intelligence, I would say, because it does seem to have an effect. One of the big things is accounting for error. The college's actual impact is not included in my tests. So the college education and what happens if they don't go, and the college's resources all are major impacts of that. And high SAT score colleges obviously have often better resources and therefore can train them even more. So it'd be interesting to see what actually the SAT score, if they don't go to college, is and how that affects their income. And then also I was taking the average SAT score, and so some colleges take different averages. Justifying my results. High scores are needed for a prestigious school that offers opportunity. Also, the wealthy go to college, and therefore they have connections already to become even wealthier. And there's a phenomenon of buying the SAT score through extreme methods of studying. And oftentimes people give into expectations based on test scores. So if you are smart, if you're designated smart, then you think you have to do better, and therefore you attempt to do better and try harder. The limitations I had were mainly about the data available to me, and I also time-wise, I couldn't do as many tests as I might have liked, and the data was not individual-based was the big thing. It was group-based, and so it was the group average of these colleges. if I could do anything differently, I would try and get more schools because a larger sample size is always better, and maybe block the design by public versus private school. I had this information, but it was just too difficult to do that and all the other tests I was doing. And then finally getting SAT scores with writing, because that would be an interesting site of whether or not with writing had a bigger influence. Like if they had a stronger SAT score with writing, then that might be different. Taking it further, if you want to continue the research, if I wanted to, or if someone else wanted to, I would apply test scores to different aspects of success, maybe happiness. I could also see how test scores relate to success within college, so test scores and then their GPA in college or even high school, and then maybe try and figure out a way to account for other possible influence factors on income, professors, extracurriculars, studying abroad, etc. So what I learned was how to apply these tests to modern day statistical problems and make it in context in real life. And it also was a great review of all the tests that we've done in AP Statistics, as I've been able to kind of figure out which test was the best for my data. Thank you so much.